Okay, we are in section 13.4 where we get to evaluate inverse trig functions. So to this point, we've been talking about trig functions, the main six, the sine, cosine, tangent, cosecant, secant, and cotangent. And if you evaluate those trig functions, you get some kind of a decimal or some values in radians, or just using square roots, I'm sorry. But when you're taking inverse trig functions, this is allowing us to find the angle of theta. So if you were to, for example, like up on the top here, if I were to write like, say like, for example, sine of theta equals something, so let's just say like it's x, for instance. Inverse sine would be written like this, but what you'd have here is you'd punch in what x is, and then it would equal theta. Okay? Again, from what we learned in previous sections, this value here of x is, or actually no, this value here for theta when you get x is a reference angle. And so it can be several different measurements depending on the value it is, whether it's positive or negative. And some of the things that we've learned in previous sections will help us discover what those angles are. One thing you have to keep in mind is that value for the inverse sine must be between -1 and 1. If it's anything larger than 1 or anything smaller than -1, the solution is undefined. So make sure that if you have a value there for a value there for a, make sure that it's in between -1 and 1. So first off, we want to be able to evaluate the expression both in radians and in degrees. So if you just punch this into your calculator, the inverse sine of -1, you get -90 on your calculator. So, and you could leave it as -90, that's fine. If you're looking for the positive degree for that, if you look here, if you were to graph it, like this is -90 degrees right here. So if I was to take this to a positive sense, it would be a positive 270 degrees. Depending on which one you want, let's just stick with the 270. So, but if I were to write that in radians, I would just take 270 divided by 180. And so it would be what? In radians, this would be like 3 pi over 2. Inverse cosine of negative square root of 2 over 2. Punch that in. It would be what? Negative square root of 2 divided by 2. I would get 135 degrees. And then inverse tangent of square root of 3 divided by 3, I would get 30 degrees. And if you didn't have a calculator, some of these ones look familiar because you can find the ratio of the values with the special triangles like the 30, 60, and 45 degree angles with all 6 trig functions. So you can find it out that way, similar to like, say, like you're looking for the tangent of what degree would equal square root of 3 over 3. And if you were to look in your chart, the tangent of that gives you square root of 3 over 3 would happen to have been 30 degrees. For these examples, they want us to solve the angle for the particular trig function, but what they want is they want that angle to be between 270 degrees and 360 degrees. So basically what that means is that they want that angle to be in uh, the fourth quadrant. So we have the cosine of theta equaling 3/4. So to find theta is we'd have to take inverse cosine of 3/4. And if we type that into our calculator, we would get something like 41.41 roughly. Now 41.41 is not in between 270 degrees and 360 degrees, but if you remember when you're dealing with trig functions, this is to give us the reference angle. So you can have 41.41 degrees here, or you can also have a reference angle of 41.41 degrees here. So if I take 360 and minus it by that 41.41, you're actually going to get something, this angle here, right in green, it looks like right here, this angle is going to be 318.6 degrees roughly, which satisfies the parameters they're looking for to be with between 270 and 360. So if you were to say type in cosine of 318.6, you would get something roughly close to 0.75, because 3/4 is 0.75. So now if I go into example B, same thing. I got sine of theta, so I have to find the inverse sine of negative 0.23. And if I go inverse sine of negative 0.23, I get negative 13.29. And again, this is another one where, but this one actually shows us the correct one, because if it goes negative, that means we're going to go clockwise, so it's going to go here, somewhere close to here, and it's going to be 13.29. And so they want an angle that's between 270 and 360, so I just got to go and find this one. So just a matter of me taking 360 and subtracting it by the 13.29, and that's about 346.71 degrees. The last thing is to be able to find the measure of angle theta. So go back to the definitions of each of those trig functions, and what they mean is going to help us determine what that angle theta is. So they give both examples A and B, they give us two measurements. For A, they give us one leg is 8 units, and then the hypotenuse is 10 units. So if I look, my theta is right here. That means that this is adjacent to that theta, and this is my hypotenuse. So adjacent over hypotenuse is cosine. So I can say that cosine of theta equals 8 over 10. And then to find what theta is, all I have to do is say, all right, I'm going to take the inverse cosine of 8 over 10, and I'm going to punch that in there, inverse cosine of 8 divided by 10, and that gives me something roughly 36.87 degrees. Last thing here, we notice that this is opposite, that's adjacent, so opposite over adjacent is going to be tangent, so the tangent of theta is going to equal the square root of 51 over 4. So to find theta, I just take inverse tangent of square root of 51 over 4. And when I do that, I get a value of roughly 60.75 degrees. And that is being able to evaluate inverse trig functions. Hope this helps. Till next time.